Good morning, my students of MTE1501. This is the second time I meet you. The first one I made myself. This one is made professionally by our studios. We are going to go through your first assignment, which is the multi-choice questions. And I think this video tutorial will be published, so you will be able to see every slide that I'm showing you now. Okay, my name is Dr. MC de Plooy. They call me Reina, and this is my email address down at the bottom. We are doing MTE 1501, assignment 1. The unique number is 682424. You will find that unique number when you enter or when you submit your assignment, but you will also find it in your tutorial letter 001 that is under your, what you call it, under your study material, your official study material on my UNISA. The submission date for this is 30 April 2021, and there is no extension to that because it is the system that marks it. It's not me. I cannot give you an extension because it is the system. It's closing on the 30th of April. It is a multi-choice question. Each question has 4 options, as you can see. I wish that you open your MTE 1501 001 next to you so that you can see the assignment 1. Each question has 4 options, 1, 2, 3, and 4, and you select only one. Just one reminder, be careful when questions ask which of the following is not. Some questions are positive, some are negative. So just be mindful of that. I want our assessment to be a learning opportunity. Not that you see that you are just assessed to get scores or to get marks, but also as a learning opportunity. And that is why we are making this video tutorial so that you can use it as a learning opportunity. We are going to questions 1, 7, and 8. These 3 questions are going together because they are covering the same topic. Let me first, okay, question 1 says, in the traditional teacher-centered approach to teaching mathematics, now you are going to choose one of these. In the traditional, now remember that's the old school type of teacher. In the old school type of teacher, learners would understand every step of a calculation strategy or method, and it has meaning to them. Or learners follow rules and steps to get to the right answer, even if they do not understand why. Learners learn the importance of mathematics because they realize it's everywhere in their lives. And the teacher allows learners to first explore a concept informally before she teaches it to them formally. So in that traditional way, which one of these? I will come to a little bit of explanation just in a while. Question 7 handles the same type of thing. The phrase instrumental understanding of mathematics means that a learner connects various mathematical ideas together. A learner remembers rules and formulae and can apply methods. A learner may remember less, but surely understands more. A learner can solve mathematical problems without a prescribed method. And question 8 says, we group 6 ideas together. Trying approaches to mathematics teaching and learning. Now we are actually comparing, in all these 3 questions, we are comparing the old, traditional, old school method of teaching mathematics to the new school, the modern way. And we are currently training teachers to do it the modern way, because we can see that mathematics taught in the old way was failing learners. So we saw that it was failing. we have to employ the new methods. So there are 6 ideas. 3 of them belong to the old school. 3 of them belong to the new school. Now, which of these groups belong best together? These ideas are constructivism and behaviorism. I will explain it in a minute. Instrumental and relational understanding, and conceptual and procedural knowledge. Right, constructivism includes instrumental understanding and procedural knowledge. Behaviorism includes instrumental understanding and conceptual knowledge. Behaviorism includes relational understanding and procedural knowledge. And constructivism includes relational understanding and conceptual knowledge. Now, all of this will become clear to you in the next slide. 2 main ways of teaching mathematics. 2 main ways of understanding mathematics. And 2 main types of mathematics knowledge. Let us go back to the 2 main ways of teaching mathematics. The first way is behaviorist teaching. Now, that is the old school. Constructivist is the new way. It's the modern way. This is the way we are training you to teach mathematics. In the old way, behaviorist teaching, the teacher is the active one in the class. The learners are just sitting there quietly and passively. The teacher is dishing out the knowledge. Learners receive it without a question. Teacher gives the methods, the rules, and the steps, and learners follow these methods, rules, and steps. Teacher regards good scores as a sign that the learners have learned well. So she doesn't mind if they don't understand, as long as they score well. And then the only visible learner work, it means the test that she has in front of them, counts as a proof of mathematics understanding. And that was the way I, for one, I'm very old. I wrote matric in 1969. I'm 70 this year. And that was the way I was taught. To an extent that when I started doing mathematics as school teacher, I was forced into teaching it. When I started that, I actually understood nothing, but I had a distinction in mathematics in matric. I was taught the behaviorist way. We don't want you to be that way, so that the learners are just sitting receiving knowledge. What is the constructivist way of teaching? Teacher creates the opportunity for learners to actively explore ideas. Teacher explains, the learners ask questions until they understand. Teacher explains methods, rules, steps, but the learners explore until it makes sense to them. They just don't need to just accept it. They can explore it. Scores are not the main purpose, but how much sense something makes. Understanding mathematics means more than tests, because there is thinking too. Now you will see on the next slides, on the left-hand side, we handle the old school. On the right-hand side, we handle the new school. So there are 2 main ways of understanding, coming from the old school and coming from the new school. From the old school, instrumental understanding. Now, what is instrumental understanding? It means I use my understanding as an instrument to get scores. Let's look down. Learners can follow methods, rules, and steps perfectly up to the right answer. Learners rely on their memory to recall or remember every step, the rule, or the method. There are many ideas, but these are unrelated and isolated. They learn every single thing as something separate. And to them, understanding is just an instrument to obtain good scores. That is how I was taught, and maybe some of you. To the right-hand side, what is the new way? Relational understanding. The teacher helps learners to make sense of methods, rules, and steps before they use it. Because steps, rules, and methods make sense the learners do not rely on memory only. Mathematics ideas are not isolated, but they are related to one another. Understanding is deep and strong, and scores is not the main purpose. Right. These are the two ways of understanding. Now we go to the next one, which is two main types of mathematics knowledge are created through these two approaches. First one is procedural knowledge. Okay, I must qualify myself here. Procedural knowledge is actually the only knowledge that is created in the old school. But procedural knowledge is also created in the new school because you need to have procedures. But procedural knowledge was the only knowledge. Learners can follow the methods, rules, and steps perfectly up to the right answers. Oh, I didn't complete the sentence. So if the procedures are done correctly, it will lead them to scores, right? On the right-hand side, conceptual knowledge is the thing that is missing in the old school. The teacher helps learners to make sense of the methods, rules, and steps before using it. So yes, they also have a procedural knowledge, but together with the understanding why the procedure. Because of steps, rules, methods make sense, learners do not rely on memory only. Mathematics ideas are not isolated, but they are related to one another, and understanding is deep and strong, and scores is not the main purpose. So they understand together with their procedure. Now you will see that the way I am teaching you is this way, this modern way. I cannot expect of you to teach in the modern way if you are taught by me in another way. So everything I do is a role model to you so that you can do it in the right way. Now we come back to question 8. We group 6 ideas together. These ideas are constructivism and behaviorism, instrumental and relational understanding, and conceptual and procedural knowledge. Now you know which of these belong together. Does constructivism include instrumental understanding and procedural knowledge only? Does behaviorism include instrumental understanding and conceptual? Does behaviorism include relational understanding and procedural? Does constructivism include relational understanding and conceptual knowledge? So you are going to look at things either in the right column of those 3 slides or in the left column of those 3 slides, because those things belong together. I just want to go back to the previous question, question 7, the phrase instrumental understanding of mathematics. So you have it on the slide. You will be able to answer that. 8 you can answer, 7 you can answer, and 1 you will be able to answer. In the traditional teacher-centered approach to teaching mathematics, you will be able to answer that question as well. Right. So we have covered question 1, 7, and 8 with these explanations. Let's go to next question. I've also grouped the straightforward questions together. In this assignment, you will find question 2 is very straightforward, and I pointed you to the paragraph here. You must read there, paragraph 1.4. Question 3 is writing numbers in place value system and 0. Who discovered that, or who were the creators of that, what nation? And the keywords that you must look for there is who started writing numbers in the place value system, and they also started with the symbol for 0. That question you will be able to answer from straight reading. Question 4. Question 4 says, let me go to my questions. the oldest mathematical objects which were discovered in Africa came from where? And I just added, perhaps it's even the oldest mathematical object in the world, and it seems that it came from Africa. And you must just read to say, where in Africa does it come from? Question 5 is straightforward. If you look at those 3 diagrams that you have in question 5, the question says, from which Greek mathematical school did the theorem come, which is illustrated in the diagrams below? Note that all the diagrams below are inscribed inside, as all the triangles are inscribed inside a circle. Now, I just wanted to clarify to you what is the meaning of inscribed in a circle. If a triangle is inscribed in a circle, it means one of the sides goes through the middle point, through the center of the circle, and the other points are connecting the circumference, the outside border of the circle. These are points on the outside. So that is when a triangle is inscribed. One line is the midline, and all the points are sitting on the circumference of the circle. Okay, that one is very clear. You will read it in your study guide, in your tutorial letter 501. Question 25 is also very straightforward. And if you look at question 25, you will see that you can find the answer in paragraph 4.4.3.1. Okay, the straightforward questions are out of the way. Let us now look at questions where I need to explain to you. Question 6 is about the Platonic solids. It says, which description does not fit the description of a Platonic solid? You have this picture, this diagram, in your tutorial letter 501. So here you find all the information you need. You can see that the tetrahedron is a 6-edged shape object. It has 4 faces and 4 points. And all of the faces are in a regular triangle form. Very important thing in Platonic solids, regular shape. The flat sides, the faces, must be a regular shape. And a regular shape means that all its sides are the same length, and all the corners or angles are the same size. So this one has regular triangles, and the next one also, the octahedron, is also made up out of regular triangles. And then the hexahedron with the 6 faces has square faces. So that's also, if it's a square, it means all the sides are the same length and all the angles inside are the same. They are all 90 degrees. Now we go to icosahedron again. The faces are regular triangles and all of the faces look the same. Now the dodecahedron is the only one that has 5 edges, or a pentagon, 2, 4, 5 pentagons on the as faces, but they are also regular, which means all their inside angles are the same. They are 108 degrees, and all the sides are the same length. So I think when you look at those, these are the Platonic solids. The question in question 6 is, which description does not fit the description of a Platonic solid? That will be quite easy for you to answer now. Let's go to question. Question 9 is about the dew board. Now, it says what is not true of a dew board. Now, when you start teaching, You will help your learners to make a due board. I have a very clumsy figure there. I made it up myself, but it is a piece of cardboard, hardboard, or anything with pins into it, pins or nails that I just made mine 100. And when you start teaching in school, you can also help your learners to do it, or you make one for your classroom. Take a square piece of a fascia board or hardboard or a soft board, and you, at the regular, you make dots, and then you put in nails. Make 100 one. That is always very convenient because it can even help them for counting, but it is not the main purpose of a due board. A due board is you put a string around, like I put those strings, you put a string around a shape. In my case, I made a triangle there. You put a string and then you move that string, for example, you move it to another position. So you teach your learners transformations, you teach them, you can see that the board starts with due. It is to say it is meant for geometry. You can use it for other purposes, but the main purpose is for geometry, to make shapes out of that. So the question here is, in question 9, which one of these descriptions is not true of a due board? Now that we have talked about the due board, I think you will be able to answer that question. Right, let's go down. Question 10. Where is a common fraction? Now, this is a very important question. The question says, a learner, sorry, will you close that door, please? A learner thinks that if a fraction becomes smaller and smaller, for example, 1/7, 1/14, 1/21, 1/42, learners think that when things become smaller and smaller, they will eventually become negative. But that is not true. I'm going to go with my cursor here to show you. Between 0 and 1 on our number line, that space is where we find common fractions. A common fraction, we will come to that later, but a common fraction is a fraction where the top one, the numerator, is smaller than the bottom one. So it means that little space was divided up. It can be divided up in any number of divisions, equal divisions. Then it means it's fractions. In this case, I divided it up in 1, 2, 3, 4, 5 spaces. So I have fifths in here. If I have 2/5, 1/5 will be here, 2/5 will be there. So if I have 2/5, it sits in the space between 0 and 1. It is only when I have a negative fraction that it will sit there. Minus 2/5 will sit there. But we are not talking in intermediate school, intermediate phase, we are not talking of negative fractions. We are talking, when we start with fractions, we are talking of this. So all common fractions of the proper type, proper fractions, where the top one is smaller than the bottom one, they all sit here. Okay, so you will be able to answer question, what is that now? 10. You will be able to answer question 10 if you understand this. Let's go on. Question 11. Question 11 may be confusing to you. It says, a teacher gives learners a bunch of number cards in any way that they think make a group, which they can explain. Remember, this is a modern way of teaching. You give your learners a lot of cards. They select the cards. You can put it open on a table and they select cards for themselves. Or each one gets these numbers. then you say to them, group them together and give me a reason why you grouped them together. So you are not dictating by saying you must put odd numbers together. You must put numbers together that can be divided by 5. You open it up and you say to them, make a group and you tell me why you did this group. Remember, this is a constructivist way of teaching. So if I asked them to do that, these were the 5 learners. They came up with these 5 answers. The first one said, I'm grouping 5 and 35, 45, and 50 together because they can all divide by 5. Now you as a teacher, you look at them and you say, you test it to say, is this true? Can they all divide in 5? I'm not giving you the answer, otherwise I give you the answer to this item. Number 2, this learner said, I am grouping together 3, 5, 7, 11, 13, 17, 19, 23, and 55 because they are all prime numbers. It means nothing can be divided into them except themselves and 1. So let's take 11. Only 1 and 11 can divide into 11. So yours as a student, as the MTE1501 student, you will test, is this correct? Are all of these numbers prime numbers? Test them down to the end. Number 3, this one said, I choose 3, 5, 15, and 45 because all of them are multiples of 3 or 5. Not and. Remember this one said 3 or 5. So you test to say, can this one be divided by 3 or by 5? Test them all. Number 4. This one said, I chose 7, 21, 35, and 49 because it is all, this first one is 7 times 1, then 7 times 3, 7 times 5, 7 times 7. It makes a pattern. So you consider all these answers and you say, which of these 4 learners made a small mistake? It's a very small mistake. You will really have to look very well to see where is this mistake so that you can understand which one has not, does not have the best reason for grouping together. Okay, you can do this one. Let's go down to the next question. Question 12, very interesting. 12, 13, and 15 go about the same thing. And it is about the base 10 and base 16 number system. You have read in chapter 1, the history of mathematics, you have read about the fact that the old people started using a base 60 number system for various reasons, very interesting also, interesting reasons. But you have to now understand, in question 12, it says, we can demonstrate to learners that the base 60 number system is still in use today. Which of the following statements does not prove that this system is still in place today? The first one is people go on pension when they turn 60. The second one is there are 360 degrees in a full rotation. Third one is there are 60 seconds in a minute. And the fourth one is there are 60 minutes in an hour. So the question is, which one does not prove that we still use the base 60 number system, I can say, in a mathematical way today? So I just want to point out to you a very interesting thing about this, the 360 degree division of the circle of a full rotation, 30, 60, 90, 120, 150. Look at the clock. Look at the watch, the old the normal old clock and watch. And you'll see that all these things, base 60 things, they all go circular. They all go round from one point to the other. The clock starts there and it goes round clockwise this way. This one starts here and it goes anti-clockwise this way, but it all goes out from a central point. That was a very important thing in the olden days, that people were thinking from a center point out. What did we do? We started working linear. You see a ruler there. In Afrikaans, it's a lineal. It's a straight edge. It is a line, like a number line. So we started thinking linear in the base 10 value system. We think linear. Okay, that first question was about the base 60 number system. And then question 13 is asking, which combination of teaching aids may best help you to effectively teach place value in the base 10 number system? Remember, we have the decimal system or the base 10 place value system. Let me first explain to you this place value thing. Because we have place value in the base 10, it means that each digit numeral that we have, they are each numeral in a number or digit in a number has a place where it stands. And that place gives it a value. So the place where this one is standing gives that one a value of 100. The place where this one stands gives that 8 a value of 8,000. So it's a place value system in the base 10. Why base 10? Because this is, where is my cursor? This one, ones, is 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, means 10 times 10, 10 is 100, 10 to the power of 3, 10 times 10 times 10, and that is 1,000, 10,000, and that is 10 to the power of 4, 10 to the power of 5. To the right-hand side, it's 10 to the power of minus 1, 10 to the power of minus 2, to the power of minus 3, to the power of minus 4, minus 5. So it is a base 10 number system, and the place where it stands in the number is helping us to understand what is the value of that number of that digit in the number. Okay, so what will you use to teach learners the place value system? Which ones will be more helpful? The place value, not the idea of how to calculate. Will that chart and a ruler, or the first one is a ruler and the Venus blocks, counters and a ruler, a place value chart, this is a place value chart, and counters, the Venus blocks, and a place value chart. So you select the ones that will most effectively help you to teach the base 10 place value system. Question 15 asks about the place value of 3 in the number 876543. You can use this place value chart and put that number in there, and you will see where this number is going. And you can use these things. Does it say it's hundreds? Is it standing there? Hundreds. Is it standing there? Is that number standing there? Or is that number standing there? So these are your options. I think this is clear. Let's go down to the next one. The real number system. A very important thing, which is also not easy to understand. Question 14, 17, and 18 are all about the real number system. Now, the thing is, in the intermediate phase, we are moving. In the foundation phase, we are only teaching natural numbers and whole numbers. Natural numbers means the counting numbers, 1, 2, 3, 4, 5, as we count naturally. And then later, in the foundation phase, we add 0. But these are still all positive whole numbers. Now, the problem is in intermediate phase, you will have to move on to the negative numbers. That concept is introduced in grade 6, and you will have to move over there. So we move from positive numbers in the number system to integers. Integers now include the natural numbers, the 0, and the negative numbers. Then we also have to move to what we call the rational numbers, the fractions. We have to move there when we are in the intermediate phase. So you can see that the most important move in connection with the number system is in the intermediate phase. It is a huge thing for you as a teacher to understand how the system is working, that we are moving, that we are expanding it. Now, question 14 asks something about something that is even outside of this. Now, outside of this, these are the rational numbers. Now we go to irrational. Rational means that we can understand it with our minds. A learner can understand it, 7/3, they can understand it with their minds. That's fine. We can still understand it. You can demonstrate it on something. You can demonstrate a half on something. You can show them by cutting something. They can understand it rationally. It is within our minds, but irrational numbers we cannot understand. If we, for example, try to get a square of a number that is not a square, it is not rational anymore. We don't understand. Pi is one that is not rational. All these numbers are not perfect squares, so you cannot get their square root, and that means they are irrational. We'll come to square numbers just now. So 14 says, which one of the following numbers are irrational? The square root of 49. So you will have to find out, is 49 a perfect square? If it is a perfect square, meaning a number times the same number, then it means it's a rational number, because the answer will be a rational number. It will be a whole number. Number 2, the square root of 7. Is it rational or irrational, according to this scheme that we have? Number 3, 0.494949. Is it rational? And I want to say to you that I have to point it out to you that if a decimal repeats in a certain pattern, it is a rational number. I just have to help you there. And then -7, is it rational? Does it fall within this group, the number -7? So here you have your guidance for that question. Let's go over to question 17, which is also related. Which one of the numbers in the fraction form below is not a rational number? Okay, so 0/3. If I divide, I have nothing, and I divide it amongst 3 children, how much will each get? Will they get something? Will they get nothing? If I have nothing. So is it rational? The next one is 3 divided by 0. Now, this is the real number system. And I must give you the guidance now. Otherwise, you will not be able to answer this. Outside the real numbers is the non-real. And the non-real says that you can never divide a number by 0. It gives you something that cannot even be imagined. And then 33 divided by 3, will that give you something within this space? And 3 over 1 will give that something in that space. Right, question 18. The difference between whole numbers and natural numbers. You can see it from this. What is the difference between whole numbers and natural numbers? From this picture, you will be able to find this. Let's go to the next. Good. Here we are. This is the explanation for, I'm going back to question 16, square numbers. I would come there. On the number line, we have 1, 2, 3, 4, 5, 7. 1 is the square root of 1. 2 is the square root of 4. And 3 is the square root of 3. Why? Because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so on. So I'm going to show you, and I want you to use this as a teaching aid one day when you get to your. We are not only talking of squares. It is the physical, the real square that we are referring to. 1 is the square, or the square root of the square 1. 1 is a square. There you can see it is a square. 4 is a square number. There we have it. It's a square. It has 2 to the side and 2 down. It was 2 times 2. It gives us 4. It is a square, a physical square. Where's the 3? There's the 3. 3 is here. Where's my cursor now? Okay. 3 is here. 3 times 3. 9 blocks. 3 times 3. It's a real square. 4, we have it there. You can count 16 squares, small squares. Where's the 5? There it is, the brown one. 5 times 5 gives me 25. 6 times 6 gives me 36. And 7 times 7 gives me 49. So when you go teaching one day, you're not going to teach squares and square roots. Show it to them. This is a square. It is really a square, physical. And why is it a square? Because it is the shape of a square, and 2 blocks, let's go to the 4, 2 blocks have been multiplied by 2. 2 by 2, or 2 times 2, gives me 4. That is the square. What is the root? There is the root, 2. What is the root here? 4. What is the root? What is the 6? 7. 7. What is the root here? 6. I made another slide on this. Square numbers and their roots. So please go back to this and use this one day in your classroom. Question 19 reads, which of the following numbers is the smallest? 15 over 4, or the square root of 15, or 3 2/3, or 3.65 squared. Now, this is the question where I want you to practice your calculator. If you don't have a scientific calculator on your laptop or your phone or the device that you are using, this is the link where you can download Casio calculator. Casio is the one that we prefer, and you can download it there. And then I just want to go through this with you. How do you do all of these? If you don't know, some of you know, but let me go for the benefit of everybody. If you take 15 over 4, use that key. Then with your arrows, you will see you can go to the top one, and there you key in 15. Then with your arrow, you go down and you go to the bottom one and you key in 4. And then you press equals. There is no enter, so you press equals. And when you press equal, it will come up as 15 over 4. And you will think, I have gained nothing. But then go to this key where it says S, and there's a little arrow to the D, and from the D, there's an arrow to the S. That means standard. The fraction there is in standard form. So 15/4 is a standard form. So you want to go from standard to decimal, because if all of these numbers are in decimal, you can easily compare them to say which one is bigger and which one is smaller. So go to that one, and then you press D, and you will see a number with a decimal. For that one, the square root of 15, you know that 15 does not have a square root. It is not a square number. So you go to this key. And when you press it, it will give you, that black part is where you put the number in. Then you put 15, and again, it will probably give you a fraction, but otherwise, if it gives a fraction, just go to D on this one, or just press it, and it will go to a decimal. So now you have two in decimals that you can already compare. Then you go to 3 2/3. Now, when you go to that one, because you want a fraction, first key in your 3, and then you key in the fraction part. And then you put 2/3, and you say equals, and again convert it. If it does not want to take that, do this. 3 times 3 is 9, plus 2 is 11. 11 on 3. And then you can do it just like you have done that fraction. The last one, 3.65 squared, you key in, you go to that one. Rather go to that one than to that one. You can go to that one and key in, but go to that one and you are safe. 3.65 you key in, and then in the top little one, the top little square, you key in 2. And the way that you move from that one to that one is by the arrow, that arrow. You move to the side. Okay. Now, okay, so I said key in calculated, into the calculator to see which is the smallest number, and this is the link for Casio Android. Go to question 20. Question 20 says, an intermediate phase learner investigates the properties of various 2D shapes and realizes that a square is actually a rectangle of which all the sides are the same length. At which level of Van Heele's levels of geometric thought is this learner? And I've just put this description here so that you can read the level. There are the level numbers, and here is visualization, analysis, informal deduction, and so on. And there's the description. So you can focus on this column, the description. What did that learner do? Did that learner see the geometric shapes as a whole and did not focus on their particular attributes? Or did the person recognize that each shape has different properties, identify the shape by that property? Or did they see the interrelationships between the figures? Or did they construct proofs? Now, a proof is a very formal thing, which normally contains a formula. Constructs proof rather than just memorize them. See the possibility of developing a proof in more than one way. It will definitely not be on rigor, because rigor is something that you will scarcely find even in grade 12. So you decide on which level of geometric thinking is this learner. Right, let's go to the next one. Next question is question 21. It is about your understanding of dimensions. So I've set out in this question, what is 0 dimension, 1, 2, 3, and 1, 2, and 3 dimensions. In short, 0 dimension is just a point, a spot. Oh, no, don't let me go there. It's just a spot on something. 1 dimension is length. So if you think that one can make a spot on a tile, then it means you can teach a 0 dimension. Is there any length that a person can measure on a floor tile? And the second dimension is area. Can you calculate the area of a floor tile? And then the third one is the length, the width, and the height. What is the volume of the tile? If you decide that the tile has a height, not only a surface, then you can know how to answer this question. The question is, which dimensions can you teach by using a floor tile? Can you only teach 2 dimensions, 2-dimensional shapes? Or can you teach 3-dimensional? Or can you teach all the dimensions? So you decide for yourself on this practical example, what can you teach? Question 24 and 22 are related, and they are about prisms and pyramids. I want you to, at the beginning of your mathematics training, to realize what is the difference. If we look at, we have a base, and when the base folds up to one single point in the top, then it is a pyramid. Think of the pyramids of Israel. It has of Egypt. It has a base, and then all of the faces are triangular, and they meet in one point, called a vertex at the top. So a prism, the difference in a prism is it does not only have this bottom, it has 2 of that bottom. The bottom sits there, and then that same bottom is repeated in the top. So there's a top and a bottom. And the sides are rectangles, squares or rectangles. They are not triangles. So for you to discern, first make sure whether you can take your hand on the bottom and on the top, and they are the same. Or can you only take your hand on the bottom, and the top will be a point. By looking at this diagram that I put here. Question 23 is about the interior angles or the inside angles of a shape. Now, I've taken different shapes, different questions. You will see that I didn't repeat the question that is in your assignment, but I've done a similar thing. Now, I want to point out to you that the interior angles of a shape can be any size. They can be 90 degrees. They can be smaller than 90 degrees, like this one, and this one, and also that one, that one. They are smaller than 90 degrees. They can be a right angle. This one doesn't have a right angle. It can be obtuse, which means it's bigger than 90 degrees. These two are obtuse. They are bigger. And then it can be a reflex angle. Now, a reflex angle goes, remember we are talking of the interior. We are not talking of these, because these would be a right angle, but we are not talking of outside angles. We are talking of the inside angles. This thing is also an angle, even though it looks like it's too big, but it's an angle. It goes from there round to there. So it is a reflex angle. It's bigger than 180 degrees. And this figure has 4 of them. That it's 1 there, 1, 1, and 1. So question 23 is about that. It asks you how many interior angles does that 2D shape have? Oh, is that done? No, yeah, it's done. It's the last one, because I have handled question 25 in a previous slide. So that is it. Good luck for your assignment. And if there is anything that you really struggle with, mail me, and then I will, if you have a problem, then probably other people also have a problem. And then I construct an answer and I put it on announcements. I will never leave you alone so that you can struggle with your assignment on your own. Good luck. Till next time.